All right, it's July 23rd, 2023, PaperStream number 8, and doing this on my personal channel just because it's an informal walkthrough video of the paper, an Active Inference Ontology for Decentralized Science from situated Sensemaking to the Epistemic comments. And it's done with a great list of co-authors. So to any of the co-authors or anyone else, you're welcome to come in, discuss. I just wanted to give this first kind of .0 on the paper just so that we could then catch up with more recent ways that we're thinking about and working about with AEOS. So the authors are myself, Shaun, Jessica, Arhan, RJ, Shady, Avel, Bleu, Yvonne, Siddhant, Amit, Jakub, Caleb, and Alexander. Abstract. In this work, we examine science from the vantage points of blockchain technology and its connection to decentralized science, DeSci. We consider science as a collective process using active inference, an integrative framework that models the cognitive processes of perception, planning, and action selection in terms of Bayesian probabilities and updating. We present the Active Entity Ontology for Science, AEOS, available as a composable and versionable system for modeling various science systems using the Active Inference entity partitioning. Such DeSci systems are considered from the perspective of bolts: business, operations, legal, technical, social. Further steps for developing and utilizing AEOS in the context of scientific ecosystems are provided. Table of Contents. Abstract. Table of Contents itself. A list of driving questions. Introduction section, Science in the Epistemic Commons, and some contrast between broadly centralized science and decentralized science. Section, Implementing Decentralized Science in the Web3 Era, covers different sections that different people wrote and edited about a few different topics that were relevant to include coming from the Web3 and DeSci space. Bolts of the C-sci to DeSci integration, or it could have been a bidirectional, and across these business, operational, legal, technical, and social interfaces. There's a discussion about how systems that have different approaches across this C-sci, DeSci continuum, they can operate still through these interfaces. Active Inference, Systems Engineering, and Science. Introduction of a few parts of Active Inference that are relevant for then presenting the Active Inference and Science integrated approach, one that is echoed by many authors before then and since, just kind of presenting that way of thinking about active inference in the scientific ecosystem. And then the Active Entity Ontology for Science itself, or AEOS. And the AEOS is kind of a specification that we'll look at the Coda page 4. It's just sort of a sketch specification, but a coarse-grained and useful one to help think about a few different areas from systems engineering in terms of active inference entities. So the paper is oriented around a contrast between centralized science, abbreviated to C-sci, and decentralized science, DeSci. Now, even when writing the paper, we were having discussions. Of course, this is not so simple as just drawing lines around which organizations are on which side of a line. However, these are broadly two existing approaches in terms of their archetypes. I think it's definitely interesting to figure out more formally what these may be. I have to say that in the paper we kind of center decentralized science, though even what could be considered centralized science. For example, a university is itself decentralized, so in a bigger sense, it's all on the continuum of centralization, decentralization, etc. But in this case, the sort of current flavors of alternatives are emphasized and brought together, while there's a lot of variation within and between these two groups. Just kind of a caveat on the more binary framing of D-Sci and C-Sci. But broadly, C-Sci is referring to different historical approaches towards studying science. I guess without a year being specified, it's not really clear. And these are questions that all the different authors had about different aspects of the current or existing scientific systems. Decentralized science is broadly referring to a bunch of different authors here putting together different thoughts about first principles, imagining what could be imagined of decentralized science, and how could people's lives and works be related. Different questions about the information environment for DSci. The introduction is going to begin with kind of a social / science as tool making and practice perspective. Science in the Epistemic Commons describes more of a complex systems recognition of different systems, like individual people and their brains and bodies or societies, and that those changes in thinking about causal relationships amongst systems from complex systems, the social structure of science has not yet adapted to embrace integrative practices. So something like transdisciplinarity is needed because the legacy disciplinary model is not able to approach this kind of orthogonal approach with the system of interest and the integrative practice, potentially multi-scale modeling that might entail. Each of these sections I'm just going to give a first pass, just overview. If another author or anyone else wants to give another shot. So, next section goes into James C. Scott and some topics like view from above and thinking and acting like a state, the type of techno-scientific logic that creates, and the sort of managerialism that and bureaucratic aspects that become involved with science in the modern day, leads to this Goodhart's Law kind of scenario where different measures that would reflect quality beyond just quantity in scientific research, as the paper says, the key metrics for tracking global scientific progress have become increasingly divorced from their ability to be replicated or have meaningful impact. Citation 1314. You can look at the end. The next section makes kind of a general point by connecting the scientific endeavor and knowledge community to pro-sociality more generally. We argue that relaxing the constraints of legibility associated with bureaucracy and its view from above could help develop the view from the ground, i.e. pragmatic understanding by practitioners, as well as the view from within, i.e. scientific knowledge in the classical sense of an objective description of system organization and activity. So, in contrast with this bureaucratic, top-down, industrialized perspective on scientific research, this paragraph contrasts it with a more bottom-up, frontline-up approach towards shaping and enabling the pragmatic understandings that arise by practitioners in the appropriate socio-cultural niche. View from within, not sure about this one. It says scientific knowledge. Perhaps could mean the intrinsic view, like the internal coherence of a given scientific model. Decentralized structures may be more capable of acting on divergent information streams. However, decentralization alone is not a mechanism that provides intelligent coordination for effective collective action. 17 and 18. There's no amount of centralization or decentralization that intrinsically is going to be adaptive for a given environmental setting. Introduces here decentralized autonomous organization, DAOs. Pretty large area, obviously a lot of different kinds of DAOs, but just broadly, DAOs here, they're digital entities. They allow for programmable digital social structures, embedded mechanisms for consensus, intermediation of trust requiring actions, and independent operation of work streams with multiple leaders instead of a top-down hierarchy. So in other words, the bottom-up structure of the DAO, enabled by cryptography in this case, supports that kind of view from the ground, and then potentially, not sure, but the record itself, or the analysis itself, the research records themselves, would reflect the system's organization and activity. So that's understanding science and different powers of different elements in the system that lend themselves to a more top-down bureaucratic hand, in contrast with at least the possibility for a bottom-up, legible, described, protocol-enforced DAO. Here there's a mention of Ontology's narrative formal documents and tools, or ONFT, which is the Vyatkin et al. 2020 paper. And this is just kind of a heuristic. It's not meant to be a exhaustive set, just one acronym, also that can rearrange to be font. Ontologies describe the languages and dialects and expertises and term sets and associations that individuals are bringing and that the knowledge system comes to embody. Narratives, individual and group level narratives and contexts. Formal documents, the specific documents of different media formats that are formal in the sense that they're part of the organizational work itself. And tools, which can be as little as only the formal documents, or there might be many, many other tools involved. So that ONFT, or font, acronym describes a few different aspects that can be understood and modeled and templated across different decentralized settings. In this paper, we model the similarities and differences between decentralized science, DeSci, and centralized science, CSci, through the Active Inference framework. Understood here is a framework addressing how living systems create an understanding of their environment and act based on this understanding. The Active Inference formalism affords an integrated account of the multi-scale dynamics shaping research, from the constitution of epistemic affordances shaping scientific practices, to the coevolution of epistemic beliefs in communities as a process of uncertainty reduction, technically described by the descent of a gradient of variational free energy. This model implies that cognitive understanding derives from adaptive control and agentive engagement rather than explicit representation. So this part, 29 through 31 citations, we'll see what they are. But the argument summarized by these citations is probably something along the lines of the representation, anti-representation perspective. And on the more anti-representational perspective, we have views on systems where the agents, like the nestmates in the ant colony, they only know what they know. They're only having the rate and the type of interactions that they know of. And so they have their own agentive engagement as nestmates. They know what they know through the Markov blanket. They don't need to engage in explicit representation of how many seeds the colony has or how many seeds are outside. So that same way can be considered the scientific system which exists in those classically inscribed formal documents, ultimately the stigmergy in the epistemic niche, and then the adaptive control in the agentive engagement of individual foragers, which might be humans or augmented or whatever. And that the activity of epistemic communities is shaped by the sociocultural constraints defining their structure rather than individual states of mind. So if we're going to describe the net synthetic activity of knowledge communities, then this is arguing that it's important to take into account these sociocultural constraints. Maybe that even includes technical constraints too, defining what constitutes the shared informational community above and beyond only the individual nestmate mind states. And to kind of form a descriptive approach, whether it's using this or that technology or not, or whether it's 3 people meeting in the field with notepads, or 3 autonomous language model agents meeting in some virtual space, it's good to have some integrated approach for description. So this doesn't mean that this is the most effective way to design a system. However, it's descriptive, pretty broad, and we look forward to using some existing ontology frameworks like SUMO, the suggested upper merged ontology, and a few other approaches to connect this with other ontology work in meta science more generally. This section, before we dive deep into head-on contrastive definitions of CSI and DSI, a primer on decentralized systems is crucial. And here it seems like one lens that's being applied to differentiate the CSI and DSI is the self-certifying systems perspective. So in a bottom-up situation, every miner for a blockchain chooses to run that software on their node. So, or an open source software community comes to some agreement, they can set their own standards, and then they have a self-certifying system. Or there's different computer systems that you can imagine fit this type of descriptor. Whereas the research unit in the university context is not self-certifying. They're self-propagating or perpetuating, or it could be symbiosis, but the lab does not author the degrees. but within their field and context, they may have an informal self-certification system, kind of by analogy, but here's describing the formal basis of the system in terms of its top-down scaffolding or bottom-up self-certifying nature. Centralized science, CSci, and decentralized science, DeSci. Decentralized science, DeSci, is a relatively new term introduced by Web3 collectives to describe the use of recent digital tools for funding, training, planning, coordination, execution, dissemination, and archival of scientific activities and assets by digitally connected communities. So, thanks to all the co-authors. I mean, each person wrote multiple of these sections, so there's a lot of perspectives that are being brought together, so there's a lot of long lists out there, and so I hope we can just read through it and hear more from the authors, because I'm just going to try to do some amount of explicitly what was written in the paper and some other thoughts. DeSci is an emerging area with multiple, potentially even incompatible forming senses, so all explorations here should be considered preliminary and partial. The term DeSci suggests, by contrast, the existence of centralized science, CSci, which would stand for the continued status quo organization of science as a highly bureaucratic activity managed by select academic and private institutions. Some motifs or patterns that are found in CSci and DeSci can be found in Table 1 and Figures 6 to 8. DeSci can be defined as the use of Web3 technologies to introduce epistemic markets through the deployment of open source and financial tools. In this view, DeSci represents the introduction of commodity markets for scientific assets and services where such markets were previously impossible, e.g. financialization through tokenization of intellectual property, scientific platform governance, peer review or curation processes, or access privileges to data or infrastructure. So another operational aspect of the self-certifying aspect of DeSci systems is they have different and hopefully regenerative couplings with what we'll later discuss in terms of business operations, legal, technical, and social. But here it's describing the business connectivities that are different. So the intellectual property that is generated by a lab in a university might go through a very different life cycle than intellectual property that is being centered around information on this self-certifying bottom-up open source type architectures. In another perspective, DeSci is seen as a set of mechanisms for bottom-up individual sense-making. This is kind of the two threads of DeSci broadly that I feel that the authors represent, among other axes of diversity, is that on one hand, DeSci is a set of tools, and it reflects new affordances for financial and information systems, and thus knowledge systems that can be connected in different ways, support people in different ways, and speak to knowledge in different ways. So that's a tool-oriented 2020 or post-2000 digital systems, cryptography angle. And that is this first part of the paragraph with the Web3 technologies. The other perspective is coming from the potentially more social sciences or sense-making view, and considers this more like the tool secondary as just the contemporary affordances for the process of individual sense-making, which is informed by the tools that we use, just as anything would be, but this other view censors the human sense-making side. From this perspective, DeSci is the capability of individual agents or communities of practice to make sense of the world autonomously by defining their own questions, language, and methodology. So, even if they were using low tech, this second view would consider DeSci as, for example, small bottom-up sense-making in local, and so online is just another setting for there to be this type of decentralization and then meta community dynamics of knowledge. Potentially coming to different community level ways of knowing or believing. These disparate views, as opposed to top-down systems which might, under the managerial imperative, seek to homogenize. These disparate views represent the distinction, without preference or judgment, between DeSci as a set of emerging Web3 tools and DeSci as a research ecology, respectively. So those are those two different senses of DeSci. Here's a discussion of tools. The broader perspective on DeSci is that it aims to reform the organization of scientific activity itself, which is expected and preferred to translate into an increased ability for science to fulfill its mandate and align with social values. So the optimistic view presented here is that through the recent deployment of technologies like blockchain, but other cryptographic technologies that support bottom-up sense-making, we have a new mode of epistemic organization available to us with legible, credible systems. And so there's an optimism that that could support knowledge communities in terms of active agents and informational agents, which will be described in AEOS later, that could credibly and legibly mandate and align with social values, defined locally or in some fractal way. We will therefore attempt to characterize the distinction between CSci and DeSci in terms of their respective organizational and structural aspects. Both CSci and DeSci aim at knowledge discovery, cultivation, and curation, but they differ in their means to this end in terms of their incentives, structure, and norms, or more generally in terms of their research ecology. One aspect of, quote, CSci is that there's an intergenerational mentorship ecology, whereas in DeSci, sometimes it's a bit more ephemeral or recent, because some people may feel like they've been doing DeSci for several decades, and I don't have any survey data, though these are the kinds of things that would be very interesting to see, like different, what is DeSci meaning and doing over the last several years, now that it's July 2023, probably around a year from this paper being published. So how is science changing? What measures do we have other than bibliometrics and bibliographic measures? What measures or metrics do we have to understand what the situation is in CSci or DeSci? But having a situation in place is very different than what is going to be described in DeSci, and I think it also reveals a tension between the two different senses of DeSci, because the techno-enabled DeSci concept can only have existed for several years in this modern sense, smart contracts and everything. However, if the sense-making perspective on DeSci is taken, then DeSci may include postcard communities and pen pals and all these other kinds of things and just reflect the decentralized percolation and elaboration of knowledge and the perpetuation of knowledge. So in that sort of bottom-up sense, it's pretty general, and therefore people maybe have been in this tradition of DeSci, like this river of DeSci broad sense. And then only recently, though, can anyone have become involved with this blockchain or cryptography-based bottom-up legible systems, distributed ledger technology techno sense. And I think the writing at many places could point out to the kinds of measurements that would just be cool to make. But broadly, at the time of this writing, there wasn't much meta DeSci descriptive work, and I'm not sure if any exists. And although one measure might be the Gitcoin donation rounds for DeSci, but that's a very proxy measure, but a really helpful system for DeSci. Though there is fundamental overlap and perhaps more similarity than not between CSci and DeSci at this incipient stage, those terms stand for a fundamental divergence in the societal and epistemic dynamics shaping the organization of research. Here we explore some of those dynamics by considering key differences between DeSci and CSci. So, CSci describes this managerial perspective on the on gaining that thinking like a university top-down perspective, on shaping the niche towards the sense-making of the researchers towards their specific technical and pragmatic purposes. This section describes some direct and indirect influences on the kind of modern university system and its relationship with a system that we call journal articles, which have a DOI nowadays, digital object identifier, and the coalition of the stakeholders, let's just say broadly, of this whole DOI system, paper game, journal system. Another way could include citations to Nostr cards or Ethereum blocks or some other approach where those types of references were just understood to refer to some of the measures that are important to track. Kind of like around the world, a resume and different lines correspond to different papers, and that's understood to be the chunk of knowledge, and they have an expected genre type and all these different features. That entire system. There are in-groups and out-groups, although more recently preprints are absolutely changing the game. So this paper, for example, was published on Zenodo, as many of our other papers are, that enables a DOI to be achieved with no gatekeeper. So we greatly appreciate Zenodo's work, and also in archiving GitHub repositories for a new release and giving that a DOI, which makes code very archivable and citable. We really appreciate what Zenodo is doing, so thank you to Zenodo. But in this DOI journal game, there are in-groups and out-groups, as well as unspoken rules to obtain funding for and publish the results of scientific literature. All these different features of the scientific publishing game, with all of its domain-specific or discipline-specific, but also general aspects. For example, researchers trying to characterize a mechanism by which a brain protein folds will need to emphasize its supposed role in curing Alzheimer's disease, when in fact any actionable outcome may be unclear or distant from the research. Citation 41. This situation provides a strong incentive for researchers to leverage the information advantage they have over administrators to grab their attention by making incredibly grandiose, possibly dishonest claims on the meaning of their research. More discussion of administrators in science. It's going to be contrasted with DeSci, governing and utilizing epistemic commons. In contrast to the centralizing institutional view presented above, research can be organized as a decentralized federation of individuals and communities of practice, each striving to address specific issues in a contextually relevant way. Such communities, by definition, lack a direct dependence on any centralizing institutions, or, at the very least, such institutions lack the ability to step in and manage their activity. That these communities do not need to adapt their language or objectives to the expectations of administrators does not make their activity intrinsically scientific in nature. So, being a bottom-up community doesn't necessarily make you a scientific community. However, decentralization offers specific opportunities to scientific communities by allowing them to focus on developing pragmatic solutions to concrete problems and/or purely advancing the epistemic understanding of the natural world they are focused on, free of centralizing institutional bias. So, if there were a bottom-up approach to, let's just say, storing genomic data with some reliability, then there could be, under one possible system, some type of economic and legal interplay that was self-sovereigntizing, by which different participants in the system felt like they were getting a fair deal, like it was their best alternative to be involved with that project, and so there was like a surplus, and that supported the direct infusion and support of that bootstrapping, bottom-up, self-sovereigntizing DeSci DAO, in contrast with the university lab, which from an operational, legal, etc. perspective is very dependent upon a centralizing force, and therefore within the lifetime of a lab or a person's career or of even academia itself or a university itself in specific, there can be a movement towards the increase of bureaucracy and bloat relative to academic research. However, while I just referred to it as bloat, it's also happening during a time of increased regulatory complexity overall. So there's a lot of different trends that happen, and that's why it's important to have a system that can describe different measured and hidden aspects of basically past, present, and future science systems. The opportunity, and a huge piece of that journal system, is the intellectual property system as well. Again, not saying it's bad or that there's any better specific alternative, but that it is all part of why people need to ask for permission to reprint a figure, all of these features that speak to the type of explicit coordination through the journal artifact, through the written word more generally, but through this genre or format more specifically as a method for a specific strain of epistemic culture that arose from the letter format. So that's all very integrated. Common goods or commons are defined as resources that are non-excludable. One cannot be forbidden from accessing them. The potential for misuse or pollution of the commons consequently necessitates governance at the scale of communities of stakeholders, and regulation needs to follow certain conditions that were initially formalized in economic sociology and recently generalized in evolutionary theory. So here is some specification of governance systems for commons. Read them here, and a discussion of how that arose from, for example, Ostrom and others' work in economic sociology, however, has found resonance with evolutionary game theory. Guilds. When we highlight the differences between C-sci and D-sci, we aim to frame a discussion on how specific kinds of organization can facilitate differences in the integration of information about the world over multiple dynamical scales and what it means for the broader scientific community. Wikipedia. Wikipedia, here playing it, providing different data and knowledge and encyclopedia functioning. At the moment, there's no appropriate analogous system to use in the organization of scientific activity as an alternative or complement to the currently dominant role of centralizing institutions in terms of their sovereigntizing capacity. So DeSci in Web3, some discussion of Web3 terminology. Web3, blockchain, smart contract, token, fungible, and non-fungible token. Web3, blockchain. Interestingly, the term Web3 was introduced by Gavin Wood, a key figure in the development of the Ethereum and Polkadot protocols, who proposed Web3 as a post-Snowden web, a decentralized web similar to the Web 1 of the early internet and in contrast to Web 2, where a small number of centralized agents control people's data, access to websites, and the web applications that many use every day. Web3 protocols are diverse, but the ones at the heart of most functional systems are so-called blockchain or distributed ledger technologies, DLT protocols, that support complex smart contracts. Blockchain, smart contract, token, fungible token, non-fungible token, DeSci. Another dialectic within the DeSci technology branch is the distinction between financial technologies, which may exactly use technically the same pieces of knowledge infrastructure as like Web 2 science or centralized science, but the financial architecture enables new types of operational self-sovereigntizing, which is definitely amenable to that sense-making bottom-up view because it enables new knowledge communities to be supported in their work, like Patreons of content creators and things like that. However, it doesn't fit as much under the cryptographic, digital identity, DAO, and cryptography side of the DeSci tools. So first there's that SenseMaker versus Web3 tech DeSci split. Now within the tech is the difference between Web3 financial tech, like tokens and everything with the market and all of that, or Web3 knowledge tech, like distributed graph databases, IPFS, Urbit, etc. Discussion of the different consequences of integrating financial marketization or information markets in DeSci. Whereas right now, if you think about the value of the knowledge that, for example, university labs create, and that graduate students and postdocs and staff and faculty create, then they find value for their contributions through promotions within their organization or funding structures over certain timelines or recognition in their field over certain timelines. That is one possible loop closure to support the value of people's contributions returning to their financial or organizational continuation. So that's the CSI approach, is it's organizational, and then from the top down, and the DeSci approach being contrasted with the capacity for new technologies to enable people to be in a X of Y multi-signature DAO, where different researchers can be credibly and visibly assigned different roles, and people can vote on different things, or there can be a zero knowledge type approach, where someone from a set of certain addresses is understood to have something or have done something. So the optimistic hypothesis is that DeSci here would entail a shift towards facilitating positive liberty to do science in a decentralized way. So in other words, really support individuals and collectives to bottom-up organize science in a way where, yes, getting finances and getting support on the business side of bolts, that is perhaps better than nothing. However, it also reflects social. It reflects social support when people get financial support, and to really integrate the capacities of diverse minds, which is what science entails and works as a function of, then a more holistic approach on what technology might be needed, like cryptographically self-sovereigntizing systems with digital identifiers and object identifiers and things like that, that would facilitate things to go, especially with financial and all these other aspects, to really become interesting in their bottom-up reach, whereas such systems are pretty local in terms of their influences in many cases, or I don't know. That's the point made earlier about what to measure and what we really know about the quantitative aspects of DeSci, and what are the measures. I think those were some of the driving questions. What are some of the measures that we are doing things at some given scale in an effective or aligned way? What are the kind of input and processing and methodology and output measures that matter? DAOs are these consensual organizations, at least the ones that we're thinking of are. In the remainder of the document, we will therefore focus on steps that DeSci can practically take right now, many of which are related to tokenization and marketization mechanisms. So that reflected some of the authors who had a lot of experience with these aspects of financial tokenization, DeSci vision, and open question. Pulling back to think about how in society, a relatively small number of individuals have full-time careers in scientific research. Those with family commitments, a significant role in industry, or an aversion to academic social systems are largely absent from the process of creating and curating widely distributed knowledge artifacts using the scientific method. So, science participation and engagement, inclusion, actual engagement with people in the intergenerational setting is, and potentially in certain ways always was, very fragile and limited. And everything is fragile and limited in this world. However, given the amount of input and central importance of this consensus system that even today seems like it has so much inertia, the question of how to integrate not every single person, not people who don't want to do a certain kind of work or see a kind of work, however, how to really integrate with the non-research world and different gradients and buffers of participatory research and just scientific communication more generally. So just a lot of open questions that different authors probably wrote. Token engineering, thinking about complex systems and the way that token engineering asks questions about systems to then model different aspects of, for example, in this case, an ocean data marketplace, which enables one of the fundamental mechanisms that information for financial, that technical for business, P2T engagement, which allows community funding of community knowledge assets. Whereas community knowledge assets in the academic world might be financially intermediated by, for example, a granting agency, or by donations from labs themselves as well. However, operationally, it would be supported from the top down as well. So, what would it be, or how would it be? Would it even be preferable if the same influence and centrality that grant-mediated epistemic commenting was carried out, that there would be DeSci-mediated, distributed, consensual, bottom-up technologies? Does it support a broader scientific engagement? Does it support actually a narrower scientific engagement, or difference, or something in between? So, a lot of interesting questions. This section describes IPFS and Arweave in terms of file systems. What are the limits of decentralized science? In its current form, DeSci is constrained by the affordances available to digital entities. Hence, the scope of scientific outputs is also constrained to research that has digital elements. This might be saying something like, because DeSci is online, it's very limited in the digital artifacts that it creates. DeSci research. Currently, most active DeSci projects primarily focus on building the infrastructure necessary to allow the dynamics described above, while only a fraction use their resources on research. As of 2022, a non-exhaustive list of DAOs and groups mentioned is available here, building on citation 65. Examples of research-focused DAOs include Vita DAO and Molecule, which have funded active projects in longevity research. Other active groups include the Governance Research Institute, Governance, and MetaGov DAO, researching governance, smart contracts, and other aspects of coordination in the Web3 space, all of which are closely related to the development of the DeSci infrastructure. That kind of brings in this social and decision-making aspect, which, in order to have the system become self-sovereigntizing and autopoietic, there have to be all these processes of some kind. There's a lot of open questions. Without long-term mentorship training and support for scientists at all career stages, it is difficult to imagine that merely increasing the extent or type of system decentralization would result in a successful scientific ecosystem. So, just saying, yeah, merely chopping up what exists to decentralize it will not necessarily improve things. So, just removing or sparsifying something itself, just like connecting things, is not across all settings and regularities going to lead to a better system over any time scale. So, the real question that's going to arise later is about, well, how do these different perspectives get synthesized and integrate with each other? DeSci publishing and review. So here's a description of some DeSci projects where different publishing and peer review possibilities occur. For example, one of the hallmark features of the journal system, although in certain small ways this is changing, is that peer review plays the role of gatekeeping as well as refinement. Whereas in the open science or decentralized science approach, there is an expectation that there is review after publication. So people like peers or anyone who sees it is able to make their assertion or comment or review on it that the authors or somebody else could take on board and update or not. But through that versioning history, trust can be built that a person has been updating their model to reflect changes that are credible and important and all this other stuff. So having that history is really important, which was important in the journal world as well. And to a limited extent, citations and bibliometrics enable people to track that, but outside of their direct field and colleagues and network, it's very difficult to know sometimes what different people's publication history's mean. So then the measure becomes not fit for function, and so we fall back to simpler heuristics. And there's the mention of Ant's review, and this is an IPFS hosted peer review system on Ethereum, so it's kind of cool. Research Hub, DeSci funding and finances. So here's some discussion of different financial income schemes or patterns for DeSci systems. One mechanism is bounties and marketplaces. This is being done with certain groups. Citations are here. Figure 1. Dynamic Research Funding Model of Science Fund. I remember Sid brought this figure in and had a lot to say on it. And I just see an infinity with whatever science fund is, which couldn't be only financial in this situation. Donors, supporters, enablers of science are able to articulate through a legal and professional interface to support education and research, which is kind of the big picture with DeSci, that the knowledge technology and the financial technology, all these other decision-making things, really become unique, not just during times of censorship or things like that, but when it can be firing on all cylinders and really be working the way that, though we often fail to describe it well, we feel like it could be happening. A few different mechanisms described for NFTs and things like that. DeSci data and knowledge markets. So this is a discussion of different of Ocean protocol and other related types of systems where data can have a value. So it's a data market, and that supports that supports people to use it epistemically and to value what it has, and for people to put up high quality available information. It's not an area I'm very familiar with. I'm always curious how people distribute valuable information. Valuable in the sense that they sell it, like an email list or a data set. And then how that doesn't just get leaked or transmitted. So how do people continue to try to add value with new data going into the future? Or what if it's a snapshot piece of information that somebody has to share? How do they ensure that it doesn't get shared? Kind of just random thought. Interoperable data standards are incentivized by a data market. So if you want to be part of the big data sets and the meta-analyses and maybe get funded for your research in this kind of a framing, it's like, well, you're going to have complete metadata. Perhaps that's one way to say it. Even if a dataset is originally published in an esoteric data structure, someone can profit by purchasing it, organizing it into a known format, and reselling it. So this is kind of a data improvement market, but that's all part of the multilateral situation that's possible. And I would improve the findability and the indexability and the inter-organizational hosting and accessibility of data sets, and making sure that data sets were improved. If there's little micro bounties for completing metadata and doing different kinds of analyses, then maybe that would enable some cool new research patterns. Also, discoverability. I think there's a big uncanny valley of discoverability between what we have now, which is definitely frustrating sometimes, but ultimately at the tip of the fingers and at the API call at one's behest, one can access broadly a huge range of information. But Also, just quantity is not quality. Not everything's available or discoverable, indexed, etc. And it's definitely different for people who have university type library access versus those who don't. However, information is available, and there's, from what I can understand as of right now, not a real decentralized competitor in terms of reliability, availability, uptime, scope, as the kinds of Web 2 or centralized systems that we currently have. Like, if every DOI that were available to a given university subscription were stored on a given decentralized system, and somehow that was also connected to a major funding resource and was able to negotiate the copyright complexity of that, it'd be a different situation, but that system does not exist. But in principle, it could. And it could be a knowledge graph, maybe a versioned knowledge graph. It could be all code, analyses, different kinds of things. That would be cool to have a data marketplace like that. The data marketplace could afford profitable interactions between academic labs and organizations in industry. Labs can sell data to companies that have AI expertise but may not have the expertise or equipment needed to collect training data. This not only allows companies to more easily find and use scientific data, but by buying such data, companies would also be funding the scientists who collected it. That's pretty cool. Not sure where or how exactly that would work. I haven't seen it in my experience, but that sounds interesting. Teamwork modeling with systems engineering. So this is kind of a different section, and it's just going to describe some basic concepts from previous systems engineering work on teams as the system of interest, and the way that high reliability organizations and inter-organizational settings have used many different teamwork models in order to compose and scaffold and construct teams for different projects. And so how can we bring that kind of high reliability systems engineering critical infrastructure perspective that we bring to constructing and engineering for bridges and planes and all these other things? How do we approach DeSci with that kind of at least an aspiration? This allows DeSci activity to be structured according to an established life cycle with needed practices. So the above sections had many, many different paragraphs and different things. At this incipient and formative stage, what may provide utility for DeSci would be a useful, unifying framework to allow for system conceptualization, design, and implementation. In the following sections, we describe a possible starting point for the integration of DeSci and CSci systems through the combined application of active inference and systems engineering. So that's the main contribution of the paper, which was definitely emergent and contributed to by all the authors, which was really awesome to see. And the two main threads that are going to come together and bring some gap filling and gap respecting to the different perspectives on CSci and DeSci, different strengths and weaknesses, and different engagements and participations. How can we at least just describe before then even specifying what we prefer? And this is kind of where we're going. So active inference is introduced. I'm not going to go into too much detail here. However, the most relevant piece about active inference that is going to be used in AEOS is basically that active inference describes active entities that can take in sensory information, that's perception, do something potentially with that information, that's cognition, and then take an action or select an action or a policy, and then have some effect back into their niche. So broadly, it's similar to cybernetics or any other agent-based modeling framework in terms of input-output structures, but there's some other mathematical details that are gone into elsewhere. Also, we can model inert objects, boring objects from an action perspective. Those are mere active inference entities as opposed to adaptive entities, or some people would say sentient entities, being the active or sophisticated entities or strange particles, in contrast with the mere or inert types. Active Inference Institute has a lot more information on those different types, but here the main two that are going to come into play are the active entities, like cognitive entities that do some cognition on input, and then in contrast, informational entities, which are going to be like niche modifications like a paper or like a document. So here's a discussion of stigmergy, collective intelligence, and the scientific epistemic niche as a kind of niche ecology with different informational artifacts, and the way that that ultimately supports any given sense maker to make the contributions that they can make. And here's figure 2, which is visualizing that. Two active entities interacting via their shared epistemic niche. For more detail on the entity, perception, cognition, action loop, and active inference, and the Markov blanket formalism comprising the partition shown here, see 90. So here's two entities, and sense states are coming in for both of them. Action states are going out. That could be a chat room. That could be the journal. It could be multiple journals. It could be a book and a journal. It could be an email and a book. It could be emails. It could be video call, because it still is modifying the digital niche and then transmitting to the other entity. So there's many systems that can be modeled from this perspective, and increasingly people are discovering new composabilities that really will help this kind of a Lego model or beyond, thinking about these pluggable and designable systems that involve cognitive entities, such that just because we're talking about maps, not territories here, gives us a lot of latitude. For example, the entity might be a graduate student or a professor, or it might be an administrator or some other role, and we can just make a huge coarse graining and talk about limited sense states that we might know about or not, and action states that we might be modeling or not. We're not measuring necessarily oxygen input and output, but it could be something broad, just like funding going into a university and the number of publications coming out, and different ways that information comes in and information goes out in the informational niche, because we're talking about the digital space. So active inference has been extended to digital systems before. A few citations are here. When viewed through this lens, the scientific process balances action selection based upon both epistemic and pragmatic value, and this process plays out across multiple scales of nested organization. So, policy selected by minimization of the expected free energy, which has an epistemic and a pragmatic value term, which supports that kind of adaptive balance that finesses explore, exploit. And if we're going to think about that as happening across multiple nested scales of organization, like individual sense-making humans, research labs, research communities, departments, and so on, then we're going to need a really composable framework to deal with all of this cognitive sophistication and niche modification, informational entities. So, how do we really model this even in a limited setting? This work reflects early steps towards leveraging this framework into a more detailed understanding of how scientific entities interact and how contemporary changes associated with the challenges and opportunities of DeSci could improve on the status quo. Here's AEOS. So, AEOS is the Active Entity Ontology for Science. And it's available also at this Coda page. So, I'm going to go to the Coda page first and just show what it looks like, and then the later sections are just going to be describing it. So here's the home page, and here's examples. So the areas of concern are described here, and this is basically what AEOS enables natural language descriptions of. So in order for there to be like a fully fulfilled funding scenario from CSI, we could say a natural language sentence like, team publishes knowledge artifact, a grant, then requests funding from funding agency which scientifically assesses the grants. And this was all defined in terms of active entities, like team and funding agency, and inner entities like knowledge artifact, grant, and also relationships like request funding from scientifically assesses and publishes knowledge. And in DeSci, we can similarly, with some overlapping entities that might reflect both that sense-making bottom-up self-sovereigntizing as well as the financialization of research side, we could say another basically natural language sentence like, a team publishes knowledge artifact a grant, then requests funding from a DAO, which scientifically assesses the grant. So this shows the structural similarity of peer review between the CSci example and the DeSci example. So that's just one possibility, but it allows an abstraction-based comparison between different entity systems, because we can then look at one system, describe it to a given level of analysis, and then perform grammatical changes or utilize language models to start to reimagine. Also, this natural language representation is aimed towards creating what we call the triple play, which is natural language, including translation, visualization, so graphical nodes and edges, some of which we'll look at, and executable cognitive simulations, because the active entities are going to be able to be described by a template type open source active inference generative model. So let's go first to entity classes. The entity classes are twofold. Active entities are those that engage in action and action selection. Could be a human, could be a computer system, could be a team. And informational entities are those inert entities. So going one level more detail, here's the active entities. And then here are the informational entities. Entity types, just 17 of them are listed here. Academic, university, research agency, government, research agency, private, companies, journals. So these are different groups that take in, or different collectives that take in and action, make action. Take in information, make action. Definitions, example, internal states. The types of systems or situations that they're involved in and what roles they play. And that's the systems engineering. And then the affordances, which is like the outgoing edges that they can engage with. The roles are the type of roles that need to be played for a given scenario to be completed. So for there to be, for example, peer review, there needs to be a peer review recipient, provider, and requester. Now, all three of those people could send each other postcards. All three of those people could send each other emails. All three of those people could work together through a journal review platform online. Maybe these people could collaborate together through smart contracts and do it like a DeSci approach. Or maybe it could be all AI autonomous agents. However it is, that is what allows comparison across different settings and say like, yes, scientific review happened here because there was a scientific review provider, scientific review recipient, and requester. And similarly, for there to be like this is just a super simplified version of the research and analysis lifecycle, that there's a research investigator, a research consumer, and an informational resource that's produced, or that serves an informational role. And so these kinds of epistemic environments, or like micro motifs of environments, can be brought to consilience across different settings. Affordances are just a bit more of a description on the edges. So here there's 33 edges, and they're defined, given an example and example motifs, and then the action and sense states are defined. So that's going to describe the Markov blanket that you need to construct for there to be, A does 1 to B, B does 2 and 3 to A, affordance 1, 2, and 3. Then you've just composed the Markov blanket or the interface or the polynomial functor that you need, because everything that's strictly defined for this engagement is defined through the affordance row in an updated, completed, verified version. And there's different kinds of input-output states that we can use. And there's no reason why we can't include synchronous models and all these other things. So financial interfaces, legal interfaces, and so on. That's the interactive website, the code page for the AEOS itself. And we continue to work with it broadly. Maybe I'll think about something like that at the end to say. But this was during 2022 when we made this. So another tabular representation of the areas of concern. Just what are some natural language sentences that could be visualized graphically and modified graphically in the right kind of studio, potentially with CAD, and then also executed as a cognitive simulation. So, scientific review, research and analysis, publishing, AEOS entity partitioning, the active and the informational entity. So here's the informational entity in orange that is getting engaged with by active entities. So it's very similar to the previous visualization, where the active entities were engaging through an epistemic niche. Now this is kind of operationalized in terms of active entities, here the blue box, and making modifications and shared reads from an informational niche. Policy selection. So what policies are you modeling? Well, you don't have to model their breath rate or heart rate. You could if you wanted to, but you choose what you want to model. And in this case, we use the standard partially observable Markov decision process discrete time model, and just use that as an example of the kind of sense-making and decision-making processes that you could model. And this could be deterministic, it could be, it could learn, it could be a sophisticated entity and do recursive counterfactuals. So modeling these active entities, human, DAO, business, whatever, is very flexible as active inference modeling is, but then the action states restrict or project down what are the digital modifications that are made into the epistemic niche. And then here's one like slightly more worked example where there's like multiple active entities making modifications to a computer system, which nests in an informational entity, but it's an active entity itself. And then it's getting input and output relationships. This could be people modifying documents or approving grants or reviews or things like that. Modifying documents, code repos, giving people information. And that unified, controlled language, visualization-oriented node and edge approach allows us to compare and contrast different motifs. So here is that node and edge representation for the sentences that were read out earlier, where in CSI and DSI we can see that there's actually a really similar triad here, where teams are requesting fundings from here a funding agency, but here a DAO. But in all other cases on this small graph, there's complete overlap. And then there's another difference between step 1 and step 2. Just as an example, here the DAO might send a fungible asset and then basically make no more constraints. Whereas here, the funding agency might send a fungible asset, but also provide constraints and opportunities. Communication can be modeled. Scientific review. Some different ways of thinking about the current scientific review process in journals. On the left, where the research investigator sends money to the journal publisher, who dispatches scientific review and eventually publishes the artifact, versus these knowledge markets, data markets that were described in the DSI system. Bolts was described. Bolts is business, operation, legal, technical, and social, which comes from Scott David's work. And Bolts is just a way to think about all these different holistic aspects of the system. They can all encompass so many different things, especially operations, technical, and social, that it's not meant to be exhaustive or not the only acronym. Just one acronym out there in the ocean of acronyms. But it helps us think about what types of functionalities and capacities and interfaces systems need to engage upon. So business, operation, legal, technical, and social. Then is a section on bolts and reliability for system science. So if a DSI self-sovereigntizing group can succeed on bolt interfaces, then they can be considered along lines of a high reliability bottom-up organization, which will hopefully succeed in an environment of high and low reliability DSI and CSI organizations. However, there are challenges with getting funding in DSI, because there's a lot of risk, there's a lot of uncertainty, there's a lot of ephemerality, and there's not a long track record of credibility with bottom-up, high-reliability research efforts, especially in certain areas. Maybe in certain biotech areas it's done really well, but outside of a few areas, there's still no long-term demonstration. And that's not a bad thing, it's just where we're at. And that kind of analysis of funding that was written in the sections above can also be applied to other aspects like the OLTNS. So this paper evaluated the opportunity to implement decentralized science and Web3 technologies from the perspective of active inference. CSI and DeSci were differentiated, and several other schisms and differences in perspective within DeSci. A bunch of different Web3 and technical aspects were discussed, and some pragmatic information on integrating DeSci and CSI through both interfaces. However, really what we argue is a tool that will help us re-understand these systems is the AEOS, which brings consilience between the active entity modeling, drawing upon active inference, cognitive modeling, and the informational entity type stigmergy models. And so some type of synthesis between those two, at least something that can be described as that synthesis between the two, would be really helpful. So some specific next steps include, in the open source active blockference package, we are developing active inference models that are implemented in the complex systems modeling framework CAD, with the goal of enabling description analysis and simulation of complex cognitive ecosystems of shared intelligence. Exploration of active inference ontologies and relationships with category theory and other formalisms. Creation of graphical user interface for DeSci CAD, to enable real-time use of AEOS in system science, ecosystem design, and operation. And exploring system designs in AEOS that scaffold and incentivize different kinds of research such as basic and theoretical, translational and applied, qualitative and quantitative work. We hope that this work has provided a useful understanding of DeSci with respect to the current CSI system in terms of what is possible now and in the future, and the interactive modeling framework in AEOS, which we will continue to develop and apply. Author contributions. Here's all of the awesome authors. So thanks everybody for joining this project. It was a super fun project. We're excited. I'll just scroll through. All right, 54 pages. Well, yeah, it's always interesting to reread a paper, and there's always cool ways that what was suggested was and wasn't fulfilled or came to be or is exactly how probably any one of us believes today. But in another sense, the paper is such a coarse-graining and celebration of different people's knowledges and unknowings, let's say, that kept the beginner's mind in this group, as I remember it, very strong. This was a really global and energized cohort of co-authors, and getting different people's perspectives on DeSci, from people who were co-founding DeSci DAOs to doing the token engineering and modeling, to researching this area from more of a human-centered sociological perspective, and everything in between. There was a lot of side discussions, and so it's just interesting to read back on that one kind of distilled paper, think about some of the fundamental, in principle and in practice, tensions and challenges. Intergenerational peer facilitation and mentorship networks are hard, and professional fabric is hard, and guild structures is hard, or some other adjective would go there. But how that plays out such that what is, although with multitudes, very small, relatively, in certain settings, DSI, or certain definitions, but in other senses, like just the nature of knowing, and to what extent we can bring our knowledge systems into better alignment with the nature of knowing, so that we can know and do more, and know and do better, and more beautifully. So I think that sense of the mystery and the possibility of the totality of DSI systems was definitely something that stuck with me from this author group. Another aspect I don't think that came up in the previous overview was the similarities and differences and the relationship with decentralized science, DSI, and open science. And I think there's a lot of angles on that. I know it's a question that's been asked many times too, but just one aspect of that comes to mind is the difference between making the outputs of research available, for example, to anyone who has internet access, let's just say, and making social, financial, operational, legal, technical, etc., bolts, inclusion, and engagement available to anyone who desires under the sociocultural constraints of the system as sovereigntizing autopoietic knowledge community rather than top-down institutional authority. So making the research available through open science is super positive. I'm really appreciative, and I think that as far, to the extent you can compare any world states and say that it's better or worse than something else, it's good that we have availability of the PDFs so that we can download a lot of research, increasing proportion, I hope, today. Again, still asymmetrical with different journals and what people can access in different affiliations, but open science helps ameliorate those asymmetries. However, it does not include, even in its scope, the type of financial and governance and other domains that DSI is helping us reimagine. And that might support the real holistic bootstrapping and parallelizing and serializing of novel, resilient, anti-fragile, epistemic, real enacted communities, not just infrastructures for, but real implicitly and actually enacted knowledge groups living and finding support the way that some potentially do today through the current systems that we understand that are described on the left side here with CSI, and the DSI side, or whatever we want to call it, is where there's so much to explore and so much to do. So that was kind of our hope with introducing AEOS, was to create a system that was able to consider both CSI and DSI systems, connect that system in principle to active inference, so it could be applied outside of science as well, so that we have the cognitive modeling ability of active inference and the niche modification analysis of just general knowledge engineering, systems engineering, and then also connect that to these multiple important perspectives within DSI tools, and also the human sense-making and multi-scale systems perspective that many of the authors brought. So, hope this was an interesting live stream for you. It was just an informal one, and as said at the beginning, I would leave it to any of the authors or anyone else to add their perspective on what I did or did not say. So, thank you. Bye.